Hi, this is Pre-Calculus Conics sections. This lesson is for periods 2B for, what's today, May 24th was HSA day and there was no class. And you're going to cover the circles and parabolas. So, if we look on the first page of this packet, which hopefully you picked up last class. If you did not pick up this packet last class, then I would stop watching for now, pick it up from me tomorrow, Wednesday, at school, and then you could watch this at home before class on Thursday. Here is a formula sheet for circles, parabolas, ellipses, and hyperbolas. Get used to this formula sheet, be able to use it given a problem, because I will let you use this on the test and the final exam so that you have a guideline of what to do. So first we got to talk about where conics come from and what exactly they are. There's some formulas here that you may or may not need for distance formula, midpoint formula, and slope. And basically conic sections come from a slice or a section of a conic or a cone. And here's a picture of two cones, one on top of the other, and they're balancing on their tips. Parabola is a slice. If you imagine a plane just slicing through right in this direction, you'd come up with the intersection of a parabola. If you go straight across, so it's perpendicular to the vertex, you'd get a circle. A slight slice to the side with a little diagonal at any point would be an ellipse. And then if you cut off two edges of the two cones, you would end up with a hyperbola, which is basically parabolas back to back. You also have a lot more involved with these four conic sections. And we're going to go through them. Circles is where we're going to start, like when. And circles, there's you should have covered in a previous math class. Of course, you all come from different directions, so who knows if you actually did it. The general format for an equation of a circle is x minus h squared plus y minus k squared equals r squared, where h and k make up the actual center of your circle. Thanks, guys. R, of course, is your radius. And notice how they're in the format of two binomials squared. That is why we're going to work on completing the square during stat time, so that you are used to putting an equation into the format of an equation of a circle. If the center is at the origin, meaning 0, 0, then the equation for your circle is simply x squared plus y squared equals r squared. To find the center of the circle, from this one right here, you just need to identify what your h and k are. Remember that based on the formula, it's x minus h squared and y minus k squared, so it's the opposite of what's inside with the parentheses. So for this first one, the center would be 3 and negative 7. The radius would be the square root of 19. Don't need a plus or minus since it's a distance. Number 2 wants you to find the equation of the circle with center 7, negative 3, and the circle is tangent to the y-axis. So they're trying to get you to think a little bit more here. Best way to go about this is to plot the center and think about what the graph would look like. So 7, negative 3. Our center would be right here. Tangent to the y-axis just means that it's touching your y-axis at one spot. So it's tangent right here. It's going to be perpendicular with the radius to the y-axis. And then the circle will just kind of go around like this. Not the best drawing of a circle. However, you get the point. So your radius length here is the same distance as it was from the origin. Radius is 7. And that's all you needed to complete the question here. x minus 7 quantity squared plus y minus negative 3 squared equals 7 squared. So the overall equation is x minus 7 squared plus y plus 3 squared equals 49.
Mr. Rice, please call extension 203. Bob Rice, please call 203.
We're almost to the back here. If you flip, there's a little review of completing the square that we also work on in AP Stat. So we're going to practice this one here. Our goal is to put it into a binomial squared, this little trinomial part. Now this minus 1 isn't helping us out, so our first step is to add 1 to both sides. So we're left with x squared plus 6x, leave yourself some room, equals 14 plus 1 is 15. Now we want this x squared plus 6x to be factored down into binomial squared. So it's gonna, since this one is plus, this one would automatically be plus. Two numbers that are the same, when you multiply them together, you're gonna get a positive. So we have a plus in here, something. And that's going to equal 15 plus something. So the way to do this is you take half of that middle term. Half of 6 is 3, and you plot it right down there inside your parentheses. And then to get that last term, you're squaring the 3. So 3 squared is 9. Think of when you FOIL your last two terms, 3 times 3, you get that 9. Now, I can't just add 9 wherever I please. If I add it to one side of the equation, to keep it balanced, I have to add it to the other. So this is also plus 9. So we end up with x plus 3 quantity squared equals 15 plus 9 is 24. Now, I know in stat we took time to solve those. We're not going to do that here, because if you look at the next equation, we just want to convert this equation so that it's in the format for circle. So x minus something squared plus y minus something squared equals your radius squared. So the first step would be to get all our x's together. I have x squared minus 6x. And then I need to get all my y's together. Pen. So I have my y squared, notice I left a space, plus 4y. And then lastly, I'm leaving another space. This 12 is really doing us no good here, because it's not going to help us out on either of these to be able to complete the square. So I'm going to put my equal sign here, and I'm going to add 12 to both sides, which means the 12 gets on the other side of your equal sign. Now, I'm almost there. I've got my x. Since this is a minus here, this becomes a minus. And I have my little squared plus y. Since that's a plus, the middle term will be a plus. And it's something here, something there, quantity squared. And then equals, and I'm going to figure out what's over here on this side. Hi.
Hi. I'm going to be leaving here in about 15 minutes because I have to stop by and pick up the car.
Okay. I probably will too. Yeah. Yeah. So half of 6 is 3. So my 3 is going to plot right down there. You can think of negative 3. I've already written that minus there. And then 3 squared is 9, so I'm adding 9 here and on the other side of my equal sign. And then half of 4 is 2, so that's what drops down here. And 2 squared is 4, so I'm going to add it on this side of my equal sign and the other side to keep things balanced once again. And then 12 plus 9 plus 4 gives me 25. Hey Arthur, I'm going to have to go when I'm done with this.
How long is that going to be?
Hopefully another 15 minutes.
So do you think I should just do it at home then?
It's up to you.
Yeah, well,
You have a 4-day weekend coming up too.
true.
You have a lot of time. But get it
It's
done.
already really late though.
Get it done. So,
All my teachers are telling me that in all the classes.
so no more video games until you're done with all your work.
I'm gonna try.
No, you will do that. Bye, Arthur. So my center, how about you do one of those things tonight and you hand it to me tomorrow morning?
Okay.
Bye, Arthur.
Bye.
Center would be the opposite of what's inside with the, in the parentheses, 3, -2. And the radius would be the square root of 25, which is 5. Now you should be able to do the circles homework, page 74, 45 through 59 on. That is in the front of your book. It's in a review section because, again, supposedly you already did circles at some point. If you didn't, well, here they are. Now we're going to flip to parabolas. We're at 11 minutes. Parabolas are something that you are familiar with. You did quite a bit in Algebra 2. However, we're going to kind of change the format just a little bit and talk about some additional parts of your parabola. First thing I want to do is look at this graph. You're going to have something called a focus point, which is a distance P from the vertex, and a directrix, which is like your balancing line, which is a distance P from the vertex as well. Now notice we have two different directions for our parabolas. One is in the format y squared equals 4px, and the other one is x squared equals 4py. Now these are for when the vertex is centered at the origin, meaning 0, 0, so you don't have any h and k on these. However, I want to flip it, so we're looking at the other side. I'm just wishing I had graphs for these. For this one, y minus k squared, you can draw yourself a picture of a graph. And this one would be going up. So, look at this format. This 4p x minus h, you're used to the equation being in the format of, I'll pick this one because you're more familiar with it, as y equals a times x minus h squared plus your k. They've just subtracted the k and then multiplied by 1 over a, basically, and come up with this 4p. So it's similar to what you're used to, but it helps to keep it in this format so you can find the focus and the directrix later on. So, find the focus and directrix of x equals -1 over 24 y squared, and then sketch its graph. So first off, ask yourself, is x squared or is y squared? Well, we can see y squared is. So y squared, we're using that first column. X squared would be the second. So I'm looking down at this column. And I see, first off, that y minus k squared, I have to have my y squared first, and any other number coefficient should be over on the other side. So I need to get rid of this -1 over 24. I'm going to multiply both sides by -24, and I end up with -24x equals y squared. If you don't like the way that that's written, you could switch it to y squared equals -24x. Now, there is no h and k here, meaning my vertex is at 0, 0. There is a negative symbol here, which tells me the parabola is going to be, if I just sketch myself a little graph, here's 0, 0, it's going to be pointing in this direction. I just now need to figure out the focus and the directrix. If I look up at my formulas, it tells me the focus is p plus h. Well, I need to find p then. 4p is right here in front of those parentheses, and I have -24. So that means 4p equals -24, or p is -6. So if I go -6 back, 1, 2, 3, 4, 5, 6, here's my focus. My focus is going to be at -6, 0. And then my directrix would be 6 in the other direction. And that's just a dotted line, linear equation, x equals positive 6. Now you could substitute those into the formulas that they have here. Negative 6 plus 0 and 0. Negative of a negative 6 plus 0. Or you could just plot it and figure it out. For the next one, it says find equation of the parabola with vertex 3, negative 2. So that's my h and k. No, I wrote x. And focus 3, 1. Find the equation of the directrix and then sketch the graph. So because I have these points and I'm very visual, I'm going to plot them again. 1, 2, 3, and then I have 1 and negative 2. So this point right here is my vertex. If I plot the focus 3, 1, that's right here. If I look back at my pictures, I can see that the focus is always inside the parabola. It's kind of like if you look at the best thought process is a satellite, how that has those bars going up into a focal point, and on the bottom where it's resting, it has that little base, and then it rests on maybe the rooftop. That this is your focus. It's inside the parabola at all times. So that tells me that this parabola is pointing up. I wasn't asked to find everything else. This is a sketch of a graph. It doesn't have to be completely accurate. So this focal point is at 3, 1. So the distance from here to here, from the focus to the directrix, is 3, which means P equals 3. So for the directrix, I said focus to the directrix, I meant vertex. It has to be 3 down. Here's my dotted line. So 3 down, that would be at y equals negative 5. And then for my equation, I'm going to go back. It's going up. I'm looking at the format that they have right here for me. I'm just going to plug in my values. It would be x minus, the vertex was 3, negative 2. So x minus 3, quantity squared, equals 4 times my p we found was 3, times y minus k. And k is negative 2. Just going to simplify it, make it look a little prettier. X minus 3 squared equals 12 times y minus 2. And I am done. Yay! I also wanted the equation of the directrix. And that was pretty much it. So now you should be able to do the homework for the parabolas on these pages. We will take a little bit of class time, hopefully, next class to review this before we jump into ellipses and hyperbolas. And if you glance through this packet, you can see that the class activities number 2 and number 3 are also attached in this packet if you want to work ahead. Thank you.